So we shall differentiate functions by first principles. So what it says is, if you have a function f of x, its derivative, which we call f prime of x, is defined by the limit as h goes to 0 of f of x plus h minus f of x, and this is over h. So that's the formula we apply. So for example, if we have f of x as 2x squared, for example, so we shall apply this formula and say f prime of x is equal to the limit as h tends to 0 of f of x plus h, meaning where there is x in f, we shall put x plus h. So we shall have 2 open brackets x plus h squared minus f of x, which is simply the function itself, 2x squared, and this is over h. Okay, so from here we'll say this is the limit as h tends to 0, so we shall just expand. So we'll have 2, if we expand we'll have x squared plus 2xh plus h squared, and we'll close and we'll say this is minus 2x squared, everything over h. We'll say this is the limit as h tends to 0. So here we shall just multiply 2. In this expression we'll have 2x squared plus 4xh plus 2h squared, and this is minus 2x squared, and we're saying this is over h. At this stage we just simplify the numerator. We'll say this is equal to the limit as h tends to 0. So 2x squared will cancel with 2x squared, and we have h common, so we shall pull out h and say 4x. Since h is already out, we are done there. We'll say plus 2h, since one h is out, and we shall say this is over h. Then we'll say this is equal to the limit as h tends to 0. So h and h will go, and remain with 4x plus 2h. So at this stage now we can make the limit to disappear by plugging in 0 where there is h. So this will be equal to 4x plus 2 times 0, and we'll end up having 4x. So that would be the answer to that derivative. Now if, for example, we have a function f as 1 over x, the same principle, f prime of x will be the limit as h tends to 0 of f of x plus h. So we have 1 over x plus h minus f of x, which is the question itself, 1 over x. Now the whole lot of this expression is supposed to be over h, meaning we are just simply multiplying by 1 over h. So continuing, we shall say this is the limit as h goes to 0 of, so we'll make this a single fraction. So we'll say we have x plus h and x as the denominator. So x plus h into the denominator will remain with x. So x times 1 is just x. And then we'll have minus x into the denominator. We'll have x plus h. X plus h times 1 is simply x plus h. So we shouldn't forget to open the brackets there. So we have x plus h, and then we'll close and multiply by 1 over h. So this will be equal to the limit as h tends to 0 of, so when we simplify, x minus x will be 0, then we'll have minus h, so on top we'll have minus h. This will be over x plus h times x, and this will be multiplied by 1 over h. So we'll say this is equal to the limit as h tends to 0. So this h and that h will go, and I'll say in the brackets I'm remaining with minus 1 over x plus h, and then x. At this stage I can make my h to disappear by plugging in 0. So when I plug in, my limit will also go. So I'll say this is equal to minus 1 over x plus 0 there times x, and this will be equal to minus 1 over x times x, which is equal to minus 1 over x squared. Now if we are given a root function, for example, if we have x, f of x is equal to the square root of x, for example, the same principle. So say f prime of x is equal to the limit as h tends to 0 of f of x plus h, which is the square root of x plus h, minus f of x, which is just the square root of x, everything over h. Now for root functions, what we do is we conjugate, or we rationalize the numerator in this case. So we have the limit as h goes to 0. So we shall multiply with the conjugate of the expression on top, meaning we shall multiply with the same quantity but with a plus instead of a minus. So we already have what we have on top as the square root of x plus h minus the square root of x over h. We can say this is being multiplied with the square root of x plus h plus now the square root of x. So the same thing even down, we have the square root of x plus h plus square root of x. So the easiest way to figure out the result of what we have in the numerator there is to remember this principle, which we call difference of two squares. So if you have such a scenario like we have on the left, this is the same as squaring x and subtracting the square of a. So in this case, what we shall just do is we shall square this term here, and shall say minus the square of this term there. So that's what we shall do. Now doing that, we shall say this is the limit as h tends to 0. So the square root of x plus h squared, the root will cancel, so we'll just remain with x plus h, and we'll say minus the square of the square root of x, the same thing, the root will cancel, we'll just remain with x. Okay, so that would be the result on the numerator, and we shall do nothing to the denominator, so we shall just write it the way it is as h, then we'll have square root of x plus h plus square root of x. We can close there and say this will be equal to the limit as h tends to 0. So x minus x will disappear and will just remain with h. So writing that, we're going to say this is h over h square root of x plus h plus square root of x. So h and h will go. We have limit as h goes to 0 of 1 over, so we shall just remain with square root of x plus h plus square root of x. Now here we shall make the limit to disappear by plugging in h. So we have 1 over square root of x plus 0 now, which is just the square root of x plus another square root of x. Okay, if we do that, this will be equal to 1 over twice the square root of x. So that will be our derivative. So remember to post all your questions in the comment section below and subscribe for more alerts on new uploads.